Vande Gujarat.
SANDHAN, All Gujarat Integrated Classroom.
સેટેલાઇટના માધ્યમથી જોડતી કડી એટલે સંધાન.
Hi friends, my name is Virali Bora and today is the second session in the continuation of what we did in the last session. In the last session, we started with understanding one of the important techniques of operations research, which is Pert and CPM. Pert stands for Project Evaluation and Review Technique and CPM stands for Critical Path Method. Let us continue with what we are going to study today. Today we shall see what is critical path analysis. We shall also introduce different floats, which are independent float, free float and total float, which is also called slack. And we shall also continue with pessimistic, optimistic and most likely time. Friends, in the last session, the last example that we solved, we learned how to introduce time to each activity on AOA network diagram. Now, let us move ahead and see what are the different types of time that we might have when we talk about any network and its activities. First, let us have a look at the different notations for calculation of various times of events and activities. EI stands for earliest occurrence time of an event I. This is the earliest time for an event to occur immediately after all the preceding activities have been completed and we make sure that it does not delay the project. Next we have LJ, which stands for the latest allowable time of an event J. This is the latest time at which an event can occur without causing a delay in already determined project's completion time. We have four main notations which are EST, LST, EFT and LFT. The full form of EST, the first one, is the earliest start time. As you can see, EST is earliest starting time of an activity IJ. LST is the latest starting time. EFT is the earliest finish time and LFT is the latest finish time. So for any activity, say A, we have four times which are earliest start time, latest start time, earliest finish time and latest finish time. We see that T stands for the duration that this activity A would take to finish. In order to calculate all these four times, we need to know the duration that all the activities would take that are involved in the construction of a network diagram. Let us have a look at how to find out the different times. First, we see about the earliest start and finish times, and then we'll have a look at the latest start and finish times. The earliest time of an event or the occurrence of an event is the earliest time for an event to occur immediately after all the preceding activities have been completed without delaying the entire project. So when we talk mathematically or in terms of graph or a network, it says that we start from the left of the arrow diagram, from where the network actually we start constructing. The very first event, which means the very first node, we start at time 0. We move on from the left hand side to the right hand side in order and compute the earliest time EI at which the event can occur. for each activity. We might come across a situation where we see that one particular activity can only be started after completion of several other activities. In such a situation, we add the earliest time of each immediately preceding event at the duration of the activity which connects it and select the highest of the values obtained. It means that if we have an activity which can only start after the previous 3 activities have been completed, we make note of the highest time that the preceding activity is taking and we add that to the time duration of that particular activity. We'll understand it with the help of a network diagram, but before that, let us have a look at what the latest occurrence time of an event means. The latest or the allowable time of the event. It is the latest time at which an activity must finish without causing a delay in already determined project's completion time. Mathematically, we start from the right-hand side, that is the terminal event or the end node of the network. To this event, we give its earliest time, which we have derived with the help of EST and LFT. Now, by subtracting the duration time for the corresponding job, calculate the latest possible occurrence time LJ from any event, assuming the final event is fixed. Here, we might face a situation where a particular event bursts into several other events. So from the latest time of each immediately succeeding event, subtract the duration of the job which connects it and select the lowest value obtained. We can understand it mathematically more when we construct a network diagram and try to calculate all the 4 types of times. Basically, when we have to calculate the earliest times, we move from left to right. And when we have to calculate the latest times, we start from the right and move towards the left. It is nothing but the forward pass method and the latest part method. Forward pass method and the backward pass method. For example, let us try to understand it very clearly with the help of this example. As you can see, we have several activities for this network starting from A till L. The arrow has already been named, namely, which means that activity A lies on the arrow 1 to 2, between node 1 and 2. Similarly, activity G lies on the arrow 5, 6, means between node 5 and 6. Also, the corresponding time that each activity takes for its completion are given on the rightmost column. Activity A takes 4 days for completion, activity B takes 1 day for completion, and so on. Now, we have already learned how to make a network diagram. So we already have a network diagram built ready for this given data. If you look at the data, you can understand and relate it with the data given. This is the network diagram for this particular example. We have activities starting from A to L. We have one start node and we have one end node. This is AOA network diagram. The numbers have been given to all the nodes as given in the data. The numbers given in the brackets next to each activity name represents the time that particular activity takes for its completion. For example, activity K takes 5 days for completion. Of course, the other information is already available, which means that activity K can only start after activity J and I have been completed. Today we'll learn how to calculate the different times. Namely, earliest start time, latest start time, earliest finish time, and latest finish time. So we are going to study how to calculate these 4 times today with the help of the information that has been given in the example. As we have seen, friends, that when we calculate earliest and latest start time, we move from left hand side towards the right hand side. We represent the EST and LST with the help of a node. This shows the EST and this will show the LST. As given in the detail, we start from 0 and we move ahead by adding the duration that each activity takes, by adding the time. As we can see, this is from 1 to 2 where we have activity A, and it says that activity A takes 4 days for its completion. So the earliest time for activity 2 is 4 days. Earliest start time. Activity C can only start after 4 days. Then activity C starts, which takes 1 day. So we add it here and we write 5, which means that activity F can only start after 5 days, which means that the earliest start time for activity F is 5 days. We move on and we add 5 to this 5 which we have, and we get a 10 here, which means that after 5 days we start with activity 5, which again takes 5 days, and so the earliest start time of the next event, which is 10, would be, which is L, would be 10. Similarly, here we have 0 and we add 1 day to for the activity B, and we get the earliest start time for activity E as 1. This 1 is the earliest start time for activity E. Then we can start activity E after the completion of activity B, which takes 6 days for its completion. So we have 1 plus 6, we have 7 here, which means that we can only start activity H and activity G after 7 days. In other words, the earliest start time for activity G and H would be 7. Moving on, this is 8. When we add similarly this duration for activity H to its earliest start time, we have here 15. And here we would have 11. Now the question arises when we have the merge of events. If you remember, it was given in the details that when we have 2 activities preceding one single activity, we take the highest time that this activity would take. Which means that if we add the duration of activity J to its earliest start time, which is 15, we see that we can have 17 here, which means that activity K's earliest start time would be 17 days. But in this case, if we go by this path, we add 1 to the earliest start time of activity I, which is 11, which gives us 12, which will say that the earliest start time of activity K is 12. But we have to choose the highest time because we cannot activity K unless both the activities have been completed. This activity will be completed in 12 days and this will be completed in 17 days, but we cannot start activity K in 12 days. We have to wait, and so we can say that the earliest start time of activity K is only 17. And finally, here also we have the merge of events K and L. We have 17 plus 5, 22 here, or we have 10 plus 7, 17 here. So we'll select the highest time that this activity takes, which is 22. This is the forward path method. We start from the left hand side and move towards the right hand side by adding the duration that each activity takes for its completion. Now, to calculate the earliest finish time and the latest finish time, we need to adopt the backward path method, which means that we start from the right hand side and move towards the left hand side of the network. As given in the theory, we simply write 22, which is same as the earliest start time here. Now, moving in the backward path, we see that 22 minus 7 would be 15. So we can write here 15. It means that the earliest finish time of activity L is 15 days. Similarly, when we go backward from this side, we have 22 minus 5, which is again 17. Moving in this direction, we have 15 minus 5, so we can write a 10 here. We have 10 minus 1, which is 9, and we see the merge of events, so we cannot simply write down 9 minus 4, 5 here. We'll wait for this answer. We have written the earliest finish time and latest finish time of these activities. Now we move in this direction. 17 minus 1 is 16. And similarly, 17 minus 2 would be 15. Now we have the merge of events. If we go